Okay, so this is Paul Pogonoski, Principal Solutions Architect for SOA Software. Just presenting the second class, or second stage in the end-to-end demo that we have around the SOA software products. If you've joined us after seeing the first stage of demonstration, you'll recall that the demonstration's all around looking at the flow of information and how that works between the different domains of governance in delivering a service or any other artifact around SOA. So there's Portfolio Manager, which is ostensibly has the workflow in there to manage the decision making of whether a service or another artifact will become produced or will be an extension, a new version, extension of existing service. There is Lifecycle Manager, which is around the governance of the delivery and design and delivery of a service. And then once that's completed, it pushes over into our runtime governance products, which is Policy Manager. And you see here on the screen we have two instances, a dev and a test, because what happens is that you never ever have one instance of Policy Manager. You always have an instance per, at least one instance per environment. That is, whether that's your dev environment, test environment, QA, staging and production environments, because those environments extensively have different rules around how they get managed. Therefore, the rules and the workflow around that management needs to go into a separate instance of Policy Manager. So we've got two here today. You'll see what happens with the automatic attachment of policies based on some rules we've put in place, and how we can promote a service once it's gone through its testing phase over from one environment to another. With the latest version of our product, there's automation involved in loading up and putting it into the target promotion systems, but you'll see us do it manually here, and we'll talk about what the applicability of that manual loading for even any instance of Policy Manager. So we'll go through there. So the previous demonstration was on Portfolio Manager and Lifecycle Manager, if you like, our design time, planning time tools, and now we're going into runtime. So today we're concentrating on these two products in this scenario in the demonstration. You'll also remember that the whole demonstration revolves around this order management or fulfillment system, where we have a number of different services, and we've had to replace an had to replace a order transportation system with the new ERP system. And that the topology in place to make this all work, because none of these services have any security or logging or anything in place, is to use our agent and an ND, network director that is, and delegates compiled and linked into every one of the services here. So, and the delegate's job is to be an intermediary for a consumer. So it knows about the policies that are where the target is, and will intercept or intersperse those needed information into the request to handle those policies that might be over here too. So we're just about to see all that happen today. So we'll flick back over into the demonstration, and what you see here is the dev instance of Policy Manager. You'll note that under we need to log back in. So we've got timed out there. Log back in. You'll note that we have this organisation tree here. So I'll talk a little bit about that and how important it is. But before we do that, I just want to point out that here's the ERP physical service. Now I'll talk about what the difference between a physical service and a virtual service is, and the difference between these little flowers here, if you like. With deeper dives and in training and understanding the products, you'll understand what these are all about. But essentially, that's what you've got. So there is this other organisation called eComp Corp here. That is created. Now, what will happen if you have Lifecycle Manager is that should be created out of Lifecycle Manager. the reasoning for all that is that inside Lifecycle Manager, if you have a look at this structure here, we've got Ecom Corp. Then underneath that, we've got Enterprise Services. And underneath that, we've got Supply Chain Management. And we've got some services underneath there. There are some services in here, but I just wanted to concentrate on this tree structure here. So if you go into Repository Manager / Lifecycle Manager, if we take a look at the groups, you notice there, if you're keen and quick, that the view between one user and another user was quite different. That's because the roles between those users are quite different. So we'll have a look here, and we note that we have under our groups list here, we have an Enterprise Services group, and if you click on there, you see it is, oh, my bad, very bad, I've chosen the wrong library. Which is a good segue into reminding you what a library is, as we talked in yesterday's class about our design time products, and we have different libraries. And you saw there that even though when I was one user, I went into a different library, and the data was totally different. So a library is like a database in a database management system, where Repository Manager and Portfolio Manager, Lifecycle Manager and Portfolio Manager are like the databases, which contain different schemas, have different uses, and have different users of it. So we want to go into the RM demo library, and then if we go onto groups, now you're seeing what I expect to see here. We have this Ecom Corp group. So if we go back over here, there's an Ecom Corp group here as well. If we drill down into there, you'll see it has children of delivery channels and enterprise services. So if we go back to here, you see delivery channels and enterprise services. And if we drill down into enterprise services, you see it has children business services, common services, and supply chain management, just like it was in Policy Manager. If we go down to supply chain management, we have enterprise services. This parent, supply chain management, is then the project, and is then a project that owns the services we put across yesterday, which were the ERP fulfillment and order management services. So which of these services here? So the point here being that the structure set up around groups and ownership, and groups being either a group or a project that's owned by a group and delivers services, ends up being mimicked through the ownership that's over here in the organisation tree. Now, that's quite important. The reason why it's quite important is not because the two products are tied tightly together, but it's the fact that what this represents in the organisation tree. A service in an organisation tree needs to have a home inside an organisation, a sub-organisation, if you will, or an organisational tree that eventually and ultimately either owns and or manages the service. So where it lives in this tree is based upon the ownership, that is, who pays the bills for the service to be maintained, who gets money if they charge for consumption of the services, and management, who's responsible for making sure that this stays alive all the time and looks after the ongoing life cycle of the service as well. So those two views are the only ones you should consider when drawing out what this view looks like. But having said that, if you're using Lifecycle Manager, you should not blindly go and create projects willy-nilly and put things underneath it, because what you do here is going to force out what happens here. So you need to have that consideration. And of course, SOA software will hold your hand in all these deliberations, because we have professional services and engagement type programs that will help you assess what you need there and finally put these structures in place. But to understand the reasoning behind what you have here is always a good first principle, understanding how you manage a service in this life cycle anyway. Now, the other thing we need to show here is under any one organization, you have, by default, a service folder, a contracts folder, policies folder, and containers folder. So let's talk about containers first. Now, a container is a very technical term. You're probably better off talking about intermediaries. So a container is a thing that holds our intermediaries other than a delegate. So here is, we have a network director named DevND, and we have a Tomcat agent named Tomcat, because these are two intermediaries that we've gotten involved in this demonstration. If you have a look here, that's these two here. So a container is a control mechanism for the intermediaries that we use. Now, the reason why we have them here is not only because it's a good place to control them or whatever, but because you then have the ability to then place services that are hosted in these containers. So you'll see here we have our virtual services here, and we have, in Tomcat, we have physical services. Now, I know they're physical services because, going back to this diagram here, you can only place physical services in an agent because they don't have any virtualization, but no place to virtualize it. You are right next to the implementation of the service, so it is a physical service. A physical service is a software term to nominate the implementation of the service. So what the endpoint is, or the URL for the implementation of the service. Whereas a network director, it's away from the implementation of the service, and while you can directly route through to the endpoint for that physical service and be seen as a physical service here, more than often than not, we recommend that you have virtual services. Now, there's two types of virtual services. There is just the virtual service, or there is a proxy for the physical service. So, and every one of these virtual services we see here, we've got do not act as proxy, which means this is now a proxy. So what is a proxy? A proxy is what its name suggests. So it is a one-to-one match to the interface definition of a physical service or the real implementation of the service. So that if the WSDL changes for the real implementation of the service, the proxy interface will change as well. Now, that's the normal approach you should take when you're putting services together, but there are instances where you don't want to have a proxy service, where you'll have an aggregation of physical services and have a different interface on there. Well, certainly not going to be a proxy. Or you might simplify or change the interface completely and do some small and simple mediations between the new interface and the old interface. Of course, then you wouldn't be using a proxy service as well. So we give you the ability to do both, but in most instances, your virtual service is always going to be a proxy service. And a virtual service, as the name suggests, is a virtual interface on the real implementation of that physical service. Now, the thing about that is, of course, is you can only have virtualizations on the network director because it's the only place where it makes sense to virtualize those kind of things, because you're away from the physical implementation and you can decide to route wherever you want to go depending on what operation's been called that you've put together for your virtualization of the service. So that's the difference between a physical service, which has got a solid little flower, and a virtual service, which has got a whited or opaque flower, transparent flower. Now, the other thing we see here is most of these have got rings around them. What that means is they're managed. They're managed by our containers. So in this case, this physical service, which is down on the Tomcat instance, will be managed by the Tomcat agent. And in this case, this virtual service, which can only be put into a network director, is going to be managed by the network director. So you can have policies, and we'll get to those next because we talk about services here, and we'll talk about containers. So you can have policies, which is the next folder down here, defined and attached to a service. Like you see here, there's two policies. There's an audit policy, which is a logging policy, and it's a diagnostic one, so it's going to record every instance, everything about the request and response of a service. And here we'll get to this one. This is the complex security policy that we have in place that does WS security username token for authentication, but also uses symbol for authorization. It's all bound in this service. You could have them attached here, but the service not managed. And what that means is that those policies are not going to be enacted because they're not made live in a container. So in order for things to be managed, for policies to be enacted, the service has to be managed. So we'll see that happening because now we've got a physical service here. We need to manage this, and we also create a virtual service that need to be managed. So we'll go through that. Now, so we've talked about containers, we've talked about services, we've talked about policies, and we want to talk about for a little bit about these things called contracts. Now, contracts are something that you would think are quite easy to understand, but usually in SOA governance end up being a little bit of a nightmare. So I'll spend a little bit of time going through this. So it won't be a great deal of time, but a little bit of time trying to make it more clear to you how contracts work with our products. So a contract ostensibly is an agreement between a service, the provider of that service, and only one consumer of that service. So it's a couple, a binding between one consumer and a service. A service can have many consumers. Therefore, for every consumer you have an extra contract. Now you'll see here on this particular virtual service, we've got an anonymous contract. So we provide that ability out of the box to have anonymous contracts. Of course, in your lower environments like dev and test, you might want to not want to have anything at all governing who can use that service and who can't. So that's what an anonymous contract is. So a contract in itself, like I said, is that binding between one consumer and the service. So what's that binding all about? Well, the binding's about being able to, identify that consumer so that anytime that consumer is making a call to any service, it's identified by the contract. So there's an identity that comes back and it's rolled back into this organisation structure here, that not only will you have an organisation structure for your providers of the services, you'll have a structure for the consumers of the services, or many structures for the consumers of your service. And these organisations will be given an identity through our security mechanism, and that identity is unique for that consumer, so that becomes part of the contract. But what else happens in the contract? Then you can bind quality of service policies. With policies, we have what's called compliance policies, operational policies, and quality of service policies. So operational ones that you know mostly about, as we've seen here, the logging and security. There can be other things like routing and things like that, but they're the main suite of policies. Now, a quality of service policy is an SLA type policy where you define what the availability is for that consumer against that service. Remember, it's always per consumer because it's always bound to a contract. And you define what the maximum hit rate is, or usage against a service will be. And you define what the min and average and max response times ought to be. Now, what you can do with those, when you do define those, then you can define threshold levels in which to raise alerts. You can create your own alerts and which to be raised off, or you can use the default alerts that come with the product. So you end up most of the time creating an amber alert or an orange alert and a red alert. So something's starting to go wrong and trending wrong when you raise an amber alert and people start to have a look at it. And if you really want something to be fixed straight away, it goes up to the red. So that goes against all those thresholds, and it's usually against an SLA policy. And an SLA policy is attached to that contract. So you'd have the bounds around what the consumer expects and how the provider expects the consumer to behave, or within the SLA policy. But you can also have a throttling policy, which says, based on another set of metrics, based on the same metrics that you might have in an SLA policy, when these metrics go off, then that user can't use that service for a quantum of time, and you can specify what the quantum of time is. So it becomes quite important to have a contract, because the contract is the binding between, again, one consumer and how that consumer utilizes that service. So, and not only is it about managing that consumer, it's about managing all consumers, because you can imagine as you're starting to build out services and you put services on different pieces of infrastructure and you've tested these out for their thresholds in performance, you know what the overall bounds are for a service are around max response time and what will happen to that if you start getting too many users happening or too many requests per second happening around that. And so putting on many, many consumers ends up having an effect on that. So you need to know what your bounds are about what consumers need to consume of those services and add that to the total of consumers you have and know whether you're getting towards a limit. So it becomes an exercise in managing and utilization of your services and moving those forward. So it helps you manage all that. So contracts move in that way. So you know what contracts you have. You know what a service has to provide for a consumer. You know, and with throttling, you know how the consumer can only use those against the service, and you know where your bounds are around capacity and capacity planning is. So that helps in that respect as well. Now, there's only one aspect I need to talk to about this organisational tree going forward is that, because we've seen that under every organisation, there's a service folder, there's contracts, and there's policies and containers. And that's around scope or visibility, because every one of these has the same folders. The point being that if you've got something defined at a lower level, it's only visible at that level and below. So if you've got something defined here, it can't be seen at this level or at their peers or at a higher level. So if, for instance, the reason why we have our network director and Tomcat in the container at the highest level on the registry is so that it can be seen and it can have services managed by these across any organisation in that registry. But if we tucked it up under supply chain management, it means that only these services could ever use those containers and nothing else could use that. So scoping helps in, again, around that management aspect of an ownership and management of the services. You have to be careful around that, because if you then want to, if you have your service in a container that's in supply chain management, but you happen to have a consumer that's out in here and bigbusinesscorp.com, it could never see those services or never utilize those services because the container is not visible to them. So that's why you need to be careful about how you structure things and where you place things. Same for policies and contracts as well. So be very careful about how you structure this tree. Against the warning here, because there's a lot of capability in that structure and how it works. So going forward then, we've now got this ERP service, and you notice that what was pushed across in the service was everything around that, all the information, the metadata that came from Lifecycle Manager, including a link back to Lifecycle Manager. In this case, it's Repository Management, because the name hasn't been changed. Link back to Lifecycle Manager about where you can find information about this service being built, and the WSDL for the service as well, all populated or links back to from Lifecycle Manager. But what we need to do now is we need to say, well, okay, we need to have this managed, because even though this is compiled and it's got the delegate already in place and it's been put onto the Tomcat server and it's ready to go, we want some logging around this virtual service. So we need to have it managed. So what we do is we say, if I can find it, manage service. So all the actions that can happen against any one of these assets over here, or any one of these entities over here, be their policies, contracts, or containers, appear in the right-hand folder over here for the actions. So what we want to do is we want to manage with a container. And you'll notice that we get an option here about whether we want the network director or we want the agent. So we certainly want the agent. We don't want to put it on the dashboard yet, but we have that option. The dashboard I'll show you. And now you'll notice that our ERP service, instead of having just a little flower, has a ring around it as well. It's now managed. So if we put any policies against this, that we will, then those policies can now be interactive. I just want to go back to the dashboard. So the dashboard is like an operational looking glass, if you like, about what can happen. So if we put up services or alerts that you want defined inside those things. So you can see the throughput in the different graphical representations of what's happening around those non-functional aspects of the service, all defined up here. As many services you put here, you can see, and you can define many different dashboards. So you can flick through different dashboards pertaining to different services in different business units, or have different priorities, if you like, if you want to. The main view of working through Policy Manager and Runtime is our workbench. So what we need to do, if you excuse me for a second, because to make this whole thing work, because we have encryption and signing within the WS Security username token, we have to generate a PKI key. Now we're just creating a self-signed one here. But you can have your own organisation's key. Either you can generate a CSR and have that created into a key by your CA, or you can already have a key already generated and import that in there as well. But for the sake of ease, we're just using a self-signed one here at the moment. Got to put a date in there. It's not going to work. You don't have to do this for every service. Like I said, this is because the way this demonstration works in security, we have to generate one from here. So at this point now, where we're saying we're finished with the physical service, and we need to create a virtual service. So we're going to virtualize this service. And you notice here in the container sections, we've no longer got the agent selected here before, because remember what I said about virtual services, physical services, and how the intermediaries work? It does not make sense to have a virtual service down on an agent. In fact, it's impossible to have a virtual service down on the agent, because to all intents and purposes, that agent is within that service. It's not within, it's really within the container, but as far as a user or consumer of that service sees, that's where the agent is. So you only get one option here, and then just use the network director. Or any network director, so any number of network directors you have in the organization. We'll just give it a port, and we'll just call it the same thing. You don't have to give the context path, but it's easy for management if you do. And usually what happens, the standard practice is to make the context path the same as the virtual service name that you're giving it. It's easy to read and manage that way. Now, again, we're not going to put this up let's just put this up in the dashboard. I'm just changed my mind about that. I just want to show you what it looks like when it's up in the dashboard. So it's up in the dashboard, you get this, then you can see what's happening, and you can do the same management aspects of here that you're having over here in these actions here. There's nothing happening on the dashboard at the moment because there's no traffic going through. We'll come back and have a look at that and see what happens when this traffic goes through this. So again, we want to create a PKI key for the same reason as we did for the physical service. So excuse me for a second, I'll just go through this and do this. Now, so we've got our virtual service, and like we said, we want to make it act as a proxy. So we're just saying we're acting as a proxy against the real physical service here. So, and usually that's what happens, and it says, beware that because you're doing this, it's going to bind it to it, and every change that's happening in physical service is going to occur in your virtual service. So it's just a warning we give. And we're now going to use some magic around our workflow that happens inside Policy Manager. So what we're saying here is we've got this virtual service that's all ready, and there's some information here, but there's certainly not the same information we have over here in this physical service. But with our workflow, we're saying, well, we've got a virtual service that is ready. And once we do that, it's kicking off a number of different actions in that workflow, one of which is to copy over all those categories and everything over there. The other one is to match the categories to a mapping between those categories and the physical services that have been defined. So you see what happens as soon as this is complete. You see now we've got policies attached to the service that we never had before, and we didn't define them as happening before. However, where we did define them was over in Lifecycle Manager, when we produced that relationship in the service down here to our technical policy set that we have, which included those two policies. So how did that work? How do we get to that? Well, how that worked is that we've got this mapping here. Then the mapping could be on individual service, or it can be up at this level of the service or this level of the service, or right at the registry, or saying, we only want this mapping to make sense only for this project that owns these services. And the mapping we have here is saying, okay, we've got two policies that's been attached to this organisation structure, but they've been mapped with a filter. And the filter has this category of environment default. If you have a look at that filter, our environment default has a value of audit pipe default. Now, why is that important? Because if you go back to the virtual service, the categories that are covered across, I can find them for you, have security default and audit default. Audit default has a value of audit pipe default. So there's a mapping that's occurred between these values, and with the mapping in the service matches the mapping in the policy attachments, they get attached automatically. So and that's what happens here. And you say, well, that's well and good, that's really good, that's really schmick. But okay, it's going to save us a bit of time, but it's not going to be much. The point about this is, as you'll see when we go forward in this, when we have a look at in our test environment, is that we will promote this virtual service, and it will bring with it all the categories and that's bound to it, that's part of here. And this physical service, and it'll bring with it that, and including the mapping to the contract that's down here. And because the mapping is different up at this level in the test environment, these policies will change. So you could, for instance, have no mapping for security at all in dev and test, and have high logging in dev and test. But when you get to the higher environments, you get lower logging, and you start to attach different security policies until you finally get to production and have this one here, which is the one you want, and need in production and staging. Without changing anything, you're just promoting the service, and because you have categories and mapping of categories in different environments, you get exactly what you want with those environments straight away, ready to use. So that's why we use this, and that's why we think it's the most powerful way, and we train our customers to use this as best we can, because it eliminates error. It eliminates error around putting the wrong policies in place or having no policies in place, and it also makes the delivery of the services more agile going forward as well. So it eliminates time. So we're at this point now where we're just about to test the service, because we've got the policies we need in place. I just want to add a couple of little policies here so we can see what's happening right down to the last bit. So we put that full policy on here, and we'll add this other one, transaction tracking. So I'll show you what transaction tracking will do. Transaction tracking will allow us to see the full call structure of all the service calls that you happen in there in the one logging event. And so we have that on all of these policies. And we have that now on these ones, so we should be able to run it. So we go over our order management system. Remember, this calls the servlet. The servlet has the delegate on it. The delegate will do rerouting. It'll apply the logging and apply the security. And we've got an order response. So we've got an order number, which means that it's worked. So we've done nothing here except run through a bit of workflow and attach manually the PKI keys needed for security, and everything has worked the way we want to. And if we have a look down here then, and have a look at monitoring, let's look at the logs. We've got a log here of that whole transaction, and we can see the request and the response for the Order Manager service. So that's what we're looking at here. I want to point out something before we go any further. On the request and the response you see there, we've got this massive set of WS security headers in here. Here's the body. That was inserted by the delegate. So you see here we've got a header for security. We've got, you'll see here, a SAML assertion. If you look down further, we've got a digest here, so you'll see the username token encrypted. This is here for that token, the binary token. And I'm lost in the forest here, but I'm sure down further you'll see the actual tokens in here as well. So all that was inserted by the delegate by knowing that the network director has policies that needed that. And instead of having to worry about coding all this stuff up and having to have attachments to different security stores and managing those security stores, we utilize the security token service, the STS that's inside Policy Manager, to generate all this via the delegate for you. Now, I want to show you the transaction events. So we see here, we saw a call to the Order Manager virtual service. It's actually called a physical service, is what you expect. Now, there's two calls to the inventory service. And you say, well, why was that? Well, we happen to know the flow of this transaction. Is the first call to the inventory service is to see if that that part is there to be fulfilled. And if it is, the second call is actually to actually get the price and to reserve it. So you can see where the operations are called here. Then it goes to fulfillment to ship it out, and then it finally goes to our new ERP to have the product go. So, and we see this whole track here, all through the fact that we have a transaction policy in place. And we can click on any one of these, and we get the same logging event for those ones as well. And this one happens, this is our ERP call. And again, you see the SOA headers and calls in here as well. If I wanted to come over to here, we have a graphical view of that track we saw earlier on. We have the Order Manager in the network director being called, the virtual service, going down to our agent, the physical service. You see it calls fulfillment and inventory. See that happening, that's split up here. And fulfillment will then call our ERP service. Now, you can, any one of these things, you can see a little key of key performance indicators against that service, which are the mean against that service for that container. So this is the physical service down here, the virtual service up here. So you can see the network latency between these two. Generally, it was 843 milliseconds on response from the virtual service, and it took 304 milliseconds, so 500 odd milliseconds is network latency. You might argue it's network director, but I could show you just statistics later on that show you that this. You can drill down and show you how that works. We're not going to go into that today. Now, the other thing I promised to show you was over in the dashboard. You see we have a little request over here, which is a request we made. And see, it was the color was success. There wasn't any errors, there wasn't any faults. And you can see as it travels through. Now, if you wanted to go back to our workbench, have a look at the virtual service, because that's the one new one, and have a look at the statistics on that, and we want to see real-time charts. Here we see we've got 12 transactions per minute out of that. And we saw these same statistics out of the last 5 minutes. Over time, of course, these variances and quantums will change. But only one transaction, you can see it happening here as we go through and the ticks through as well. And we can change that, slow it down if you want as well. We can then we won't show you the historical charts, but we've got a number of charts that we can bring up through different type of metrics that we have. You can have a look at usage responses, usage, and whatever increments you want as well. So what I've shown you there is the fact that we've planned this service, we've built this service. At the time we've built the service, it's pushed it over into our runtime governance product, ready to go. We've used the workflow in the runtime governance product to put the policies that's needed to govern this service that were defined inside the design time tool in place, and we ran it without doing anything else, and we have the product working. So we're at the point now of going and showing you how workflow works and how promotion works between two different environments. So you notice we've got a promote to test action down here in our workflow. So if we click that, what happens is a bundle, a zip bundle is generated and put into a predefined and configured directory, and the directory can be anything at all. It's up to you to configure it how you want to. That will be then picked up and moved across to the next target environment. Now, you can have a daemon that's sitting there running with a script, whether it's in Windows or Linux or Unix, that looks at that directory, and every time there's something put in that directory, you'll pick it up and run an SCP or a file transfer, whatever mechanism or product you use to move it over to that other environment. Or you can have an NFS type mount, so a network mounted file system. So it's been shared between your different environments, so that where that directory is actually on the shared NFS mount. And so over in the target, because we provide you with a daemon that runs, that looks in the target directory, it'll pick it up and import it straight away. What I'm doing in this demonstration, though, is going to do it manually to show you how those steps work. So you notice first thing before we go and have a look at that our workflow's changed. It's gone to either workflow import complete or workflow import failure. Now, usually these will get triggered and called back by the targeting system. But if something goes wrong, you can also manually click on this as well. So let's go and see if we've found go over here. So you see, before we had 3 files in drop-off directory. Now we've got a 4th. So, and this one today was created. So what we'll do, we'll just create our SCP command. What we're saying here is this is where we're putting this file. You can see here's the target, which happens to be needs to change. I'll get that later. I just want to change this zip file. Right, give me 2 seconds. Right. So we're copying from that output directory, that whole zip that has all the information we want, the metadata we want, to move it across to the other server. Sorry. Just got the copy in the wrong place. Okay. We've moved it across, so we're all fine. So I'll go across to the other server now. And if we do an just to see the time and date. see we just created this file over here. Like I said, you can automate this, or you might want to do it manually. Some of the customers explicitly don't want to use automation and want to do it manually because they want to make sure that they can kick off their own script that runs at any one point in time of day, only one time of day, that'll pick up these changes and move them across, so you don't have interference during the day if someone accidentally kicks off some workflow to do promotions or whatever. So it's up to every organisation how they want to do this. So we've got that in place. So what we want to do now is be able to import it. Now I've just got to Alt-Cheat and get the old command that I used. Make sure we use the right file. And before we do that, just to make sure there's nothing up my sleeve, log out. This happens to be the test policy manager. Have a look under Ecom Corp, Enterprise Services, Supply Chain, in our services. And we see we have no ERP service here at all. Nothing physical, nothing virtual, nothing defined. So we'll go back to here, we run our import. So it tells us what our import's doing, and we've got a success. Come back here, refresh our organizational tree. And we see now we have a virtual service, a physical service, with everything that was attached to it from the dev environment attached to it again in the product environment. Now, the thing here is that you'll notice that we've got a diagnostic service here, and we said we weren't going to have this in place because over here we had the diagnostic defined here. So I'll just go and detach that one and attach another one. Place the filter on it. Come back to our virtual service, and now the policy's changed. So that's how simple and quickly it is to set up a one-time only definition around the policy mapping and have it flow through. Excuse me for a second. I'll just, right, that's better. Flow through to the services underneath that. And now, because everything's moved across, all we need to do now is run the Auto Manager in the second environment, the test environment. And it doesn't work. Such is life with the demo. So what have I done wrong here? So everything should be moved across. We've got a contract in place. Services are fine. Let's go and have a look under the Auto Manager and see if we can tell us under the logging if there's anything wrong there. So there's no logs found there. Let's go and see if it can tell us Anything in the log? Nothing here. It just doesn't want to work for us. Maybe we'll just wait a little bit until it goes across and settles itself down inside the different environment and different. Just check that we've mapped them properly, that we have our services mapped. Yes, there's our virtual service. And there's a physical service. The other thing that we do when we move this across, just as a sideway discussion around this, is that when you're moving between environments, your physical service will have a different endpoint on it. But your WSDL, we haven't changed. So how do we get around that? Well, we have what's called a migrations property file, and does two things. It allows you to define a mapping and change the endpoint of the WSDL from where it was, what the name, the URL that was in the previous environment to the URL in this target environment. The other thing we do is we map the keys for the containers because they're in the UVI registry just like everything else, and they have their own keys. So we say, well, what the key was in dev for the dev ND, I don't know why it's got dev ND instead of test ND here, is what we'll pick up and put over to this ND, and what we have in dev in the dev Tomcat agent, we'll map it to this one. So our virtual services then get put into the right containers and get managed automatically as well, so they're ready to run. So everything should look like it's in place, and I'm not quite sure why it isn't running, but it definitely isn't running. So we might just stop the demo here, and I'll see if I can get it working, then we'll pick it up again, and we'll just do this last little bit and splice it in. What's going on? See if we can have a look at the logs. Go on slow also, start up. These are old ones. Oh, why is it looking there? To make sure. You're not going to work right unless you're connecting properly. It's quite strange. Oh, right. That's probably why it wasn't up yet. Here we go. Right. There you go, Ryan. You got a taste of debugging there for trying to find out what was happening. The Tomcat server, the Tomcat agent, wasn't pointing back to Policy Manager. So it wasn't able to get hold of information in a Policy Manager or report back to Policy Manager its status. So that the agent itself wasn't going to work properly because it wasn't told about the services it had to manage, like the ERP service. It just got put onto there, and we tried to manage it, but it never got told by Policy Manager to manage it. So once we fixed up the metadata exchange so that it could talk properly to Policy Manager, which is a policy decision point, whereas the AO agents and intermediaries are policy execution points, we got the right metadata to be able to make the right decisions. And once it started up properly, it made the right decisions, and the app worked perfectly in the end as we needed. Brian, do I need to just recap and go back again, or do you think you could put that together properly? So why don't I just pretend we're at the point where we're going to run it again and just run it through from there? So you could use either or as you need to. Okay. Right, so you can see we're now at the point where we've had everything moved across by promotion and automation. It will be in the end, but I did it manually to show you the steps. From our dev environment to our test environment, you see all the policies are in place, including the change of policy, because we had a mapping change. You can see the virtual service came across, and including the policies still attached to it. They came across, and we can see that all the contracts are in place. So everything that was defined in our dev policy manager and needed to help run it in our test environment has been moved across and changed as needed. So when we go to our application and run it, it should just work. So we have an order number there. So we can come back here, have a look at our order management system, go to monitoring again. Well, that's intriguing. That's intriguing. Why did I get surprised there? You'll notice that it has logged things, but there are no payloads here. And there are no payloads because we have the standard logging on that says don't log full payloads to and from. Just log the fact that it's happened and log any errors that have occurred in between there as well. So we go back to our monitoring. And we get what we're told to get. And unfortunately, though, transaction tracking hasn't worked. And we could debug that some other time, but we should be able to see the real-time charts. Okay, our requests were made. And you should have dependencies in place. So order manager. No, we don't, because the tracking hasn't worked. So we're dependent on that. But so apart from the fact that our tracking hasn't worked, and it's a bit strange as why that's been the case, and it may just take a little time for it to pick up and fulfill the database through information, everything else has worked. So you can see we've just moved it across. You can automate that as soon as possible, and as soon as it goes across, it's ready to be tested without any changes in the environment, because you've set it up once and it's only worked once. You set it up once, and it can work as many times as you need it to work, because that's the only work you need to do, one-off setup, and everything else will work as needed in the environments. So going back to our demonstration flow, a governance flow, you've seen that we started off with an idea. We've seen if that idea was needed to be built as new or as to be a service that was in a new version of a service and extended it. We then started to build it and govern the building of that through the checks and balances we have in Lifecycle Manager. It then pushed it over automatically into Policy Manager. We use workflow to attach all the services, the policies that were already defined under the design here in Lifecycle Manager and make it work. You saw it work. We then pushed it over by promotion utilising automation that we have, but I'll show you manually how to do that into the test policy manager. It ran it over there, ran straight away without any changes at all. And that will happen down the flow until it gets to production. Of course, you saw the changing in the policies depending on the environment one or two. So obviously when you get to production, you've got the right policies in place for production, assuming that all the tests have worked out the way you wanted to. And of course, you can come back and regress and picks up policies or picks up services and push them through the environments again as you need to, all via workflow. And that concludes the demonstration that we have for you today.